Hi, this video is about the three principal states of matter, which are solids, liquids, and gases. Well, what I want you to have in your mind is this visualization of the particles at the molecular level of the solids and the liquids and the gases. And so that's what this picture is here. So we're going to look at into detail about the different physical properties of solids, and see, here's a solid, and then if you heat it up you can get a liquid. Heat it farther, you can get a gas, or if you cool things down you can go from a gas to a liquid, and then cooling even more will give you the solid. So let's talk about the principal physical properties of solids. Okay, so here's our little cartoon of solids, and these little squiggle lines here are to show you that the molecules are actually vibrating. So the particles are very organized. They're close to each other. They're just vibrating back and forth, so they can't move from one place to another, and they can't rotate. They're just vibrating. They have strong intermolecular forces, and we're going to look at what intermolecular forces are in a following slide, but it just means that there are forces that holds the particles close together. And you cannot compress a solid. There's really no space to push these particles even closer together. They're already touching and quite close. So let's go on to a liquid. As you can see here in this little picture of a liquid, the particles aren't nearly as organized as they were in the solid state. They're close. They're not necessarily touching like they were in the solid state. Now, these particles, they're still vibrating, but they can also do rotation, which means that they can turn around, they can rotate. So that's something new that the solids cannot do. And a few, and very few of them, can do something that we call translation, which just means they can move to another place, but not very many of them can do that. They have weaker intermolecular forces, so they're not stuck together quite as much. And even though there are some spaces between the molecules, you still cannot compress a liquid. All right, well, let's look at gases. There are completely random positions, and so here the little blue dot is the gas molecule, and then the arrows are just showing this one's taken off in this direction, this one's going in this direction, and so forth. The particles can rotate and they can translate, so that's what this arrow is. You know, these particles are moving around. They're far apart, and because of that, you can compress gases. So you could put pressure on them, and you could make these molecules get closer together. That's what it means to compress them. And there is no intermolecular forces in what we would call an ideal gas. Okay, well, how do we change from one state to another? Well, we are changing the kinetic energy of the particles. We can add or we can remove energy, and energy is usually in the form of heat. So really, the big difference between these states of matter really is how much energy do they have. So here we are, our vibrating solid molecules, nicely organized. We add some energy. Our molecules get a little farther apart. They start rotating a little. And we are in our liquid state. We add even more energy, again, usually in the form of the heat, and we break those intermolecular forces. The molecules essentially just take off into the gas state. But if we were in the gas state and then we remove energy from the gas, then we can condense back down into a liquid, and now the molecules are closer together. There are some intermolecular forces, and they're rotating and vibrating. And then if we remove even more energy, we can go down to the solid state where the molecules don't have enough energy now to rotate, and they're just vibrating. All right. So I told you we were going to tell you what intermolecular forces were, and so here is the slide. Folks who are in honors chemistry, you're going to have an additional video about intermolecular forces. Sometimes you may hear people call them IMFs. These are forces that are usually attractive forces that exist, and this is the key word, between two molecules. So here we have a water molecule, and here we have another water molecule. And the intermolecular force is what exists between these two molecules. What would cause these molecules to kind of stick together to form the liquid phase or the solid phase? So that's what an intermolecular force is. And I want you to know that definition. It is the force that exists between molecules. All right, now, a lot of times this is the way you'll see it in a chemistry textbook. This dotted line between these two water molecules is representing the intermolecular force. These lines connecting the atoms, those are bonds, and an intermolecular force is not a bond. It's a force that is between two different molecules. Now, here's the deal. What this really has to do with is negatives and positive charges attracting one another. And so here what you see here is your oxygen, remember electronegativity? It was really electronegative, and so it's going to have a slightly negative charge, and the hydrogen has a slightly positive charge, and so they kind of stick together. Let's talk about changes in phases. So let's talk about melting. That's when a solid turns to a liquid. The solid particles, remember, they are so nicely arranged and the particles are vibrating slowly, but as you add energy, they start to vibrate faster. You're giving them more energy. So you're heating them up, you're giving them more energy, their kinetic energy is going up, they're vibrating a little faster. Then they start to break those intermolecular forces because you've given them enough energy to do that, and they start rotating, and then we'll get to the liquid state. Once you're in the liquid state, it can vaporize, evaporate, boil, all words meaning the same. You're going from a liquid to a gas. Now, in the liquid state, the molecules are still touching, but they're vibrating and rotating. Add more energy, and they start to have some translational movement, which means they can take off. They can just go from one place to another. This is when the intermolecular forces are completely broken, when a molecule takes off. And now we're in the gas state. Now, you can sometimes skip the entire liquid state altogether, and so when a solid goes directly into the gas state and the molecules never go through the liquid state, it's called sublimation. And this is a pretty picture. Iodine crystals sublimate just slightly above room temperature, and this would be a solid iodine down here, and there's no liquid iodine in this dish. It's just all going directly into this purple gas up here. Something else that sublimates at room temperature is carbon dioxide. Carbon dioxide is in a solid state. We call it dry ice. And the reason, first of all, it's very cold. I think that's where they get the word ice from. And it's dry because it never melts. It just goes directly from a solid into a gas. All right, all of these phase changes that we've talked about are endothermic. We were putting heat, or we were putting energy into the system. So melting, vaporization, sublimation are all endothermic. And remember, from the very beginning of the year, changes in states are physical changes. And endothermic means we're putting energy into the system. Well, let's look at the opposite, the processes that are the opposite, like liquid now going to a solid, where we're removing energy, removing heat from the molecules. That means they slow down. Then the intermolecular forces can start to take over and form a solid. Not only are they slowing down and they're getting closer together, the molecules now have to get organized and get back into the crystal structure. Condensing is when a gas goes into a liquid. You're removing heat from those gas molecules so they start slowing down. The intermolecular forces start to grab those molecules, and so we're forming the liquid state. And condensing, you can see that when you have a cold soda can on a warm day, those liquid water droplets on the outside of the can is condensation from the air. All right, well, you can go from the gas directly to the solid state. It's called deposition. And that's where heat is removed or energy is removed from the molecules. They slow down. The intermolecular forces now play a major role, and you're forming the solid state. These processes that we were just talking about, the freezing, condensing, and deposition, they're all exothermic physical changes. In other words, we were removing energy from the system, and that energy, when we remove it, has been released to the surroundings. All right, so I really liked this picture that we had earlier in this video, and so I just wanted to end with it. Again, our solid, we have some vibrating molecules here. We add energy to them. They start to vibrate faster. They start to rotate. You're breaking some of those intermolecular forces that are holding the molecules close to one another, and you get a liquid state. You add a little more energy, you know, here they're rotating and they're vibrating, add a little more energy, and now they can start moving around. They're breaking apart from one another. They're no longer touching at all, unless they just randomly run into each other, and we're in our gas state. And then if we removed energy, we can go from the gas down to the liquid, and from the liquid to the solid. All right, well, I hope this helps you understand what's happening at the molecular level and these three common states of matter.